Okay, so let's put this equation here. We've got tan x is equal to negative 1.6, again in the range 0 to 360 degrees. So what have we got? We're concentrating on this part of the graph, okay, because the range is 0 to 360. And what we're doing is we're going to draw a line to represent y equals minus 1.6. So where would y equals minus 1.6? Well, I'm on the negative part of my axis. It doesn't really matter where you draw your line. I'm just interested in where the cuts are taking place. So I'm going to draw a line across here at minus 1.6. I've got a cut there, okay? And if you think about it, there is another cut, okay, taking place here. Because if you imagine this graph, okay, we've got another line going down here, like this, our asymptote. So we have actually got the curve, if you imagine, coming down like this, 0 at 360, and coming round like that. Okay, so I've just extended my graph that little bit further to go and get that second cut. Why? Because this is a graph that repeats itself over a period of 180 degrees. So let's have a look. Technique, just like we've been solving all the other equations, we need our scientific calculator. We're going to get rid of the tan by doing tan inverse. We're going to see what answer comes out from our calculator. There are a couple of possibilities. It might give us that angle. It might actually give us this angle. Very similar to what happened in the sine question. So let's have a look. Let's go to our calculator and do x equals tan inverse negative 1.6. What comes out of your calculator this time, again I've rounded, okay, is 58 degrees. But not just 58 degrees, minus 58 degrees. So what has your calculator done is it's given you this cut, that cut there. So what has it told you? It says one of the answers of tan of an angle to make minus 1.6, if you did tan of minus 58 degrees, you would definitely get minus 1.6. Why isn't it one of my answers though? Because it's not in my range, 0 to 360. What are my answers going to be? I need one answer here, somewhere between 90 and 180 degrees, and my other answers here, so it'll be an answer between 270 and 360 degrees. What am I going to do? I'm going to use the symmetry of my graph, the fact that it repeats itself, so I'm going to shade this bit inside here, because I know that my calculator has told me that is 58 degrees. I know it's minus 58 degrees, because that's where its cut is, but that is 58 degrees. Okay, that space is being represented as 58 degrees. So if you actually think about it here, okay, we're trying to find where I've got that 58 degrees again. All right, that's what I'm looking for. I'm looking at where does that 58 degrees match up again in relation to the rest, okay, of this question. So we've got a line here, okay. Where's that line taking place again? You think about it, it's taking place here, okay, again, all right. So what's it actually telling me, okay, is it's telling me that if I drew that line there, like that, it's telling me that that space inside there is also 58 degrees. So if I do my 180, okay, take away, okay, my 58 degrees, that will give me the first angle that's inside my range. And if you think about it again, if I drew a line here, it's telling me that this space inside here is also 58 degrees. So my two answers are 180, take away the 58 degrees, and 360, take away the 58 degrees. So my solutions are x equals 122 degrees, and 360, take away the 58 degrees, which comes to 302 degrees. How can I check I'm correct? Just put the 122 inside this expression here. We get tan of 122 makes negative 1.6. Tan of 302 degrees also makes negative 1.6. You should now have the skills to be able to solve trig equations, whether they're positive trig equations, whether they're equal to negative numbers. Now to finish this lesson off, just for the next 5 minutes, I'm just going to show you an extremely clever way of being able to do all of that without drawing the graphs. The reason we've drawn the graphs is a lot of the time when you're asked to do this, you have to sketch the graph first. So I've gone through that whole process, but there is a very, very smart way of doing these equations, and that's what I'm about to show you. Okay, and you will definitely enjoy these next 5 minutes.